from tomorrow. Yeah.
What's up guys, it's Kevin. Welcome to the video. Today I'm going to talk about what's called a teabag rocket, and I found it on the internet and I had no idea how it happened, but I wanted to do some research and figure it out, and I thought we'd talk about it today. So first I'm going to show you how to do it and what you need, and then we're going to talk about the science that's involved and how it happens and that. So anyway, what you'll need for it is you'll need a tea bag, obviously. I used like a Lipton, just a generic tea bag, and then scissors, and then you'll need a lighter. And so you're going to get your tea bag, you do a little snip on the top, cut the top off, and then it'll unfold like a wallet, and then you pop it out like a cylinder, and then you're going to put the cylinder just up on the table like that. So then you're done with the scissors, you're going to get your lighter, you're going to light it up on the top, and it's going to slowly burn until it gets pretty close to the table or whatever it's on, and then it's just going to float right up in the air, and you're going to be mind blown. So that's how you do it. So let's talk about the science behind it.
Minus 7 seconds.
Kevin,
The science guy.
so how does this work? What happens to make this bag fly in the air at the end? And the first thing we're going to have to talk about is the difference of density. And I'm talking, when I say difference of density, I mean the difference of density in between the air inside of the cylinder and the air outside of the cylinder. And because of those spread out particles, the air inside is much less dense. So that less dense warm air rises above the cooler air. But why does it rise above the cooler air? What makes it do that? So you've probably learned by now that the warm air will rise and the cold air will stay at the bottom. And this is the main reason that it flies up in the air, because the heat causes the molecules inside to move really quickly and spread out. So when the bag is burning, it generates a hot, less dense air inside and above the bag. And this leads to a convection current, which is rapidly rising hot air above the flames. And that space generated by the hot air inside of the cylinder wants to be filled up, so that cooler, denser air that's outside of the burning cylinder moves in from underneath, and it fills the space under that heated air. And that's what causes it to lift up in the air. So the bag burns and becomes both ash and smoke. And that hot smoke rises and lifts up and flies into the air. So now all that remains is this delicate frame of ash. And since it's so lightweight, the force of the rising hot air is just strong enough to lift it upward. And as it's rising, the ash cools, so that's why it falls down back onto the table eventually. So I thought I would give you guys also a connection to the real world, and what does this experiment have to do with things that we're making today, and you know, do we use this concept in anything today? And we do. So hot air balloons use a really similar concept. They actually have a rapidly heating burner inside of the balloon, and that expands the air. Our experiment, on the other hand, used a bit of a mass change to help the ash fly, which really isn't something that an air balloon would utilize because, you know. So instead, the hot air balloon is heated much, much hotter than our tea bag, obviously, and it's heated much hotter on the inside than the outside. And that makes a trapped, less dense air within the outside air of the air, you know, that it's flying in. So it uses pretty much the same concept, which I thought was really cool. So guys, thanks for watching my video. I hope you enjoyed it, even though you're kind of forced to watch it. It's okay, it's okay. Rate me well. Also, I hope you guys actually learned something today. I would say until next time, but there's probably not going to be a next time. So I'm going to end with a corny outro where I light this thing and walk that way. I can light it.
Somewhere in the sky.